Today we're talking about scientific notation. Scientific notation is used for really large numbers of large value, like the one that you see here, or really small numbers of small value, like a decimal number that is showing a very small value. We're going to start talking about the ones that are of large value. The first thing to consider is where the decimal is. And as you know, this is 1,704,000,000 right here. And if I gave you that many dollar bills, one, you'd be very rich. The other is that you could write this with 2 zeros after it in terms of money. So the decimal always goes at the end if you don't see it. And that's where we're going to keep it. The next thing that we need to talk about is scientific notation format. Scientific notation format looks like this. It has to have one digit and then a decimal right after it. Then any other non-essential zeros go here. What I mean is like this one. You're going to take the 1 and put it here, and this is 704. This 0 is very important because it holds that, in this case, the hundredths place. But these zeros don't matter because in a decimal, the zeros after a decimal at the end don't matter. So that's what we do for this. We can get rid of these zeros for this part of the scientific notation because these zeros and these places are going to be represented in this exponent. Once you have written this part in the times 10 with the exponent slot empty, we then count how many loops. 1, 2, 3, 4, 5, 6, 7, 8, 9 loops it takes to move the decimal from here to where we put it into the format. 9 loops, that gives us an exponent of 9. Now notice that I count every loop in between the numbers until I get to where it's going to be. This is the format. Let's say that my number was 1,800. I can even write that into scientific notation. Again, the format is the same. I have one digit, and then the next number, non-essential zeros do not have to go there. This is times 10 to a value. Here is where the decimal is. 1, 2, 3 places is how many it had to move to get to where I needed it in my format. That becomes my exponent. For this one, we're going to do the same type thing. The format is still the same. And again, I have to have one digit before the decimal, so that's going to be the 3 because that's the first one in the number. The 4 goes after it. In this case, I see the decimal, and I'm going to move it to where it needs to be, which is right here. 1, 2, 3, 4, 5, 6 loops. So that becomes my exponent. But in this case, it has to be a negative exponent because I'm making a smaller number. I'm indicating that that negative exponent indicates that the value of this number, when put into standard form, is a very small decimal value. I'm going to do one more of those so that you can see that. If this were the case, again, my decimal, this is the format. I can't change the format. The 8 goes in the first one. So right here, I can put a 0, or honestly, this could just be 8. And then I'm going